Hello. It should be okay now.
Yeah, I can hear you.
I can hear you as well.
Awesome. Okay, let's get started. Today is
Professor, I can
somewhat-
barely hear you.
What happened?
Can you move closer to the mic?
I am. The mic is in my mouth.
Okay.
Oh.
It sounds like you're really far away.
I'm not sure. I'm holding my phone near my lips, so it's like all right. I don't know what happened. The last 3 sessions we've been having this problem, but we have to put up with this. Okay, so are there any questions for me from anybody, anything? No questions. So I know about 4 people submitted their video. I did view them and taking notes. I'm waiting for the others to submit the project. Please do that. It's an important part of this class 1/3 to see what you have done.
Professor, I have one question regarding that.
Yes.
I'm probably like submitting like either like tonight or like tomorrow, but I was just wondering, what time is it due on the 10th? Like, when's the latest submission for the on the 10th?
Well, you should submit it as fast as you can.
Right.
But
Yeah.
I generally do not impose deadlines. So therefore, I have to tell you the same. I cannot tell you something else for you.
Right. Okay.
Submit it as soon as you can.
Yeah,
Because
definitely.
I have to submit the grade within 24 hours of this class, and my 5-week summer starts right the day after. This class ends on July 12th. July 13th, my 5-week session starts. So I have no leeway. I have to finish the grading that day. So whatever I have, I'll grade, sum it up, rank it, put it up there.
Right. Okay. Thank you.
Okay? All
Yep.
right.
Gotcha. Understood.
Okay, so you should be seeing my notepad. Lesson plan for today is pretty large. If you want to see what are all the subject matter, we are going to talk about relational algebra, what it means, and some examples of that. Then we are going to talk about transactions. Then we are going to talk about index. Then we are going to talk about view. There are 4 different topics. So let's get started. Unless somebody has any trouble any issue with anything, I'm going to be talking about all these things over the next couple of hours. As far as the class program is concerned, this is the last class. Next Monday, the 12th, we will not have a class. Instead, if you should log on to Blackboard. You will see a final test. I will be available by text or email. I won't even join that session, most probably. Right, so you do that. It should come up at exactly at 5 p.m. and it will end at 8:10. So you should meter yourself, submit off, save off. Don't do what you did in the first test that some of you had not submitted. And there should be a question on normalization, that is taking a problem statement, creating attribute catalog, and then doing 1NF, 2NF, 3NF, explaining what you did, why you did, and some queries based off of that problem and based off your normalized schema. Is that clear to everyone what we are planning to do for the rest of this course? Not just today, but on Monday. Is that clear to everybody, please?
It's clear.
Yep.
Okay, so let's get started with today. Again, somebody is typing. I have no way of reading that. And I have requested, said a lot of things over the last 6 weeks. And fortunately, people have not considered it. Okay. All right. So you've written this very large query, and you need to explain to somebody, right? And it's not useful or particularly, let me pick up some queries from something that but I'm not doing this lecture, those questions today. So let's see whether so here I'm showing you some queries. It's the same topic. I diluted it. I didn't want to deal at this level of detail, so I boiled it down to something else, right? Suppose in that small firm system, we had vendor table V and action table, which had actions like verified, authorized, or approved and paid. Then we can run a query like, bring me all the invoice numbers where the action is like 3%, like it has been verified, and it has been approved, and those invoice numbers are the same. So the same invoice has been verified, approved, but that invoice number is not the paid, but the action is like payment, right? This is saying intersect of approved and verified, but not paid. Suppose that's what we want to find. Here is a query that we will run, right? But if you look at this table, it's so hard to understand this. Even if I go to SQL format and I format it like this, it's somewhat better, but still it's testing your brain, right? How do I make all of this simple so that I do not go through this mumbo jumbo of from and where and all these other things I don't want to speak. I want to be mathematical speak, right? So where only the essential is there, everything else is not there. That's where the relational algebra comes into play. Where in the relational algebra, we have a simple notation. An operator, options to that operator. What are the objects operate on? The operand, right? So for this section, let's consider that we have two tables, T1 and T2, and these have columns like C1, C2, C9, and they have compatible values of V1 through V9, right? A simple example would be select star from T1. This would be in relational algebra. You're bringing in all the tuples from this table without any restriction. Every record, it will come out. Every column will come out. Therefore, relational algebra says just T1. If you mention T1, it's the same as the laborious wordy syntax. Does this make sense what the objective is for the Okay, so now let's complicate it. Nobody's answering me, so I'll go keep moving forward. Let's say we complicate our query a little bit, and I say select star from T1 where C1 is greater than V1. The operator select is the filter. It doesn't concern the project. It's just projecting all the columns. It's not concerned about that. Project happens after select complete. The first thing that happens is all the rows that are eligible to be included in the result set. Then project comes in, says for these rows that are eligible to be included in the result set, what are the columns that need to be included? So first is select, then is project. So we will handle it in the same way. So if I want to select star from P1 where P1 is greater than V1, for the filter operation, these are the options, right? So it's saying select as S, the option, as in this rotation. And it is going to operate on a table T1, which follows this syntax here, right? So S is the operator, this is OP, and that it is greater, that the option for that is wherever the column, whichever record column 1 is greater than vector 1, and on this table are set P1. Suppose we complicate this even further and say select star from P1 where P1 greater than V1 and P3 greater less than V3. Then fill the operator is yes. These two things are your options for this operation. And the table it acts on is P1. End of story. Now let's look at, is this clear, how the select operator works? If you look at internet literature, they will use Greek symbols and Latin symbols, and those symbols do not add value. Yeah, they make you feel like you're dealing with some abstract and very complicated neural material. But to me, it's nonsense to be using sigma, pi, theta, Greek, all of this, delta. I don't need to use any of that. S is there, S is select. I'll use S for select. I'll use P for project. I'll show you what the other operators that I think of. You don't have to remember another thing. Everything is right there. You don't have to say, it's rho this, it's pi that. You don't need to worry about it. Just use the first letter of your operation, and you are good to go. Hey, if your mic is not working, you can do what I'm doing. Just call that number, and you will be able to speak. Now, so for project, we're going to say, we are going to project column 1, 2, 3 from this table 2. So we'll again use this notation. So our operation now is P. The options for this operation are C1, C2, C3. Its operand, the table upon which it will act, is T2. Right? That's our notation. To say, I am projecting everything from this table T2. Therefore, the next logical sequence is, what do I do for this grid, where it's selecting C1, C2, C3 from P1, where C1 is greater than P1. So there is this select operator, which then gets projected. Therefore, we start with project. Remember, project and select are not commutative. The reason should be fairly obvious, because if I project only C2, C3, right? Suppose, why is it not commutative? P and S are not commutative. What does it mean? PS is not equal to FP. That is, if you operate select first and then project, that is not the same as operating project first and select next. I'll show you an example. Suppose I have this operation, right? So this works. So let me change this query to do P2. When I get rid of projecting C1, I'm only projecting C2 and C3 where C1 is greater than V1, right? Suppose somebody says, okay, now this is doing yes first, the select first, and then it's doing project, right? Now, if I say, no, they are commutative, let me try to do this. And I'm going to put this up like this, where the C1 now is this guy, P of C2, comma C3, and from this table T1. You can see right off the bat, project operator is not even projecting C1. So therefore, this is going to fail because it is saying, well, look for this column C1 and see if the value of the column is greater than V1. If so, include that row for in the result set. So this is okay. F followed by P is okay.
Sorry, Professor, can I just interrupt you? I have
Yes.
a question.
Yes,
Uh,
sir.
Can you scroll up a bit? I'm still having trouble understanding. C1 greater than V1. Is it saying all values in column 1 that are greater than the value 1?
That's not what it's saying. It's saying it's testing, right? It's a predicate. If you look at, let's see, I'll show you an example. I hope you are able to see my MySQL session.
Yes, I can see.
So I have select star from A, and when you say select star from A, where X1 is greater than, this will fail also because only after project the X1 will work. So this one would work, right? So what's going on here is this is a select operation where C1 is greater than 0. And let's change it so you can see the effect of this. If I say that, only one row comes out. Only one row comes out. It's saying, go to the table A, find every record where this column C1 has a value greater than 2. So we have 3 records, 1, 2, 3. Therefore, this condition is satisfied only by the 3rd record. So that's the only thing that's coming out. I am actually using the rename operator to say, I'm going to take this column 1 and rename it as X1, right? So in the output, you don't see the column 1, you see X, because rename has taken place. Is that clear where C1 greater than 3 or 2 does what it does?
Yes.
Okay, good. It's these are filter operations, therefore they're predicates, and if they are true, such records will be included in the result set.
So what is P, the projection? Can you explain that again? I think I
Yeah,
kind of...
projection. Yeah, that's very important. projection is a list of, remember, again, I'm going to state it not so easily, but with some basic in it, fundamentally, right? So relational database is an orthogonal closure language. This is a complete language which only generates sentences within that language, right? This is a fundamentally mathematical property. And the way they enforce that is by introducing operations which are orthogonal to each other, right? So select operator, the filter, its impact is what row. It will not touch the column. By doing this, select star from C, where condition 1 and condition 2, you can do any kind of tricks you want to do in the where clause. None of that will have any impact on the column. The record will have all the columns that was in the table T. So what operates on the rows will not impact any column or the column structure of your data, right? So this is something very clearly should be understood. Relational databases provide a set of operations which are mutually orthogonal. They don't influence each other. You can combine them. Therefore, since they are orthogonal, now combine, right? That's how we are doing. That's how we are able to combine project with select, rename with project and select, blah, blah, blah. All those combinations we have seen throughout the course are made possible because the operations are atomic and they do not interfere with other operations. So the projection operator is to take a result set and say, in this result set, there are 8 columns. Which of those 8 columns do I want to include in the final result set? You have to look at E followed, let me complete this thought here, is not okay. Because column C1 does not exist. Select test predicate cannot be evaluated. And we can see this, we can simulate it, say, right? Let me simulate that here to show you what happens. So let's first do a select star from A, right? This is give me A. Everything is A. A project of C2 is this. This I have projected only the C2 column. I've left out the C1 column. Now if I say select star from, I'm going to say select C2 from A. I'm going to call this as B, where C1 greater than 3. This won't work. Why? So this guy is projecting C2, so the knowledge that C1 was part of A is gone, right? C1 was part of A. We have that. But this projection operator that we did here says, yeah, I got A and it's got C1 and C2, but I'm going to project only C2 out. C1 is not visible, right? So once this is done, this rename operator says, whatever was projected, call it as B. And from this B set, select all the rows with C1 greater than 2. But C1 doesn't exist. There is no such column. And that's why this is saying unknown column C1 in Bertrand. Right? And therefore, that's the reason that we pull up everything. This up here so that okay, so it is that clear now, Angus? Is that clear?
Yes.
Okay. Okay, so we cleared this out. The project and the select operators are not commutative. Now, using the same logic, you could try writing cross join, natural join, equijoin, left order for everything I've given you the symbol. And remember, everything has operands and options. This is the symbol. We are going to universally follow this syntax, no matter what the operation is. And it can get hairy because if you use this, right, if you take to your manager this instead of this, it simplifies, it reduces the cognitive load. You only have a few characters to read and process. And as the query becomes more and more useful to the business, they're not going to be trivial like this. They're going to be much more complicated. So this relational algebra will reduce the cognitive load and allow people to exchange ideas clearly and easily, efficiently. It's got very simple semantics. There are these operators, and as I have been saying, we are going to use the first letter or first two letters where we need to do this. And you need to think about, if I'm going to group by, what is this output, right? So for example, let me see what I have here. Okay, so I have all this, right? Here I have student ID, course ID, course mnemonic. Now, I could say select this is a perfect want to find the number of students taking any particular course. So I'm going to subset them and I'm going to count it, enrollment, and I'm going to change from this is my SU, whatever that is. Let me see, what is the table? To summer 1, 2021, first normal form. That's what we had. This we seen 4 weeks ago, if I remember correctly. Now, to do this without the group by is wrong. It won't work. For counting, and you're counting with a record level detail. Notice the difference between this and this. If I get rid of this C mnemonic, then I can do a count star. Why? Because there's only one set. You're treating the entire table as a set. Therefore, it's able to do an aggregate function of counting the members. It makes sense. It's working. So you might be tempted to say, why can't I do this? You cannot do this because now the count star is 79 or whatever that is, and C mnemonic will be different things from different records. So the whole set that it generates will be of no meaning to anybody. It'll give some course name and it'll list 79 as a count, which would not mean anything in general. So therefore, you cannot mix the record level detail with a aggregate set level detail. So how do we counter this? We have to say now subset it by the mnemonic. If it is that, this is perfect. It'll say, okay, I've got the 8 subsets. Now I can count the number in each subset, push it out. This makes sense. Okay, so here's our equation. So who can tell me what is being projected? What is being projected here? Let's try to write this relational algebra for this query. What is the relational algebra for this? What is the project? What's being projected by this query? Understand?
Is it C mnemonic?
Yes. So we can start with that. We can say, no, it is projecting two things, right? It is projecting this.
Yes, C mnemonic and count, right?
Yes. And the count is being renamed.
As enrollment.
Yeah, as enrollment, right? So we could say, I'll show you why. I will explain how enrollment becomes visible. But that's what is being projected. Now, where is this being projected from? This is being projected. This is the operation. This is being projected by this group by operation. If options are to the group by thing to group it by the mnemonic. And what is it projecting? What is it? What should I say? What is it subsetting? It is this guy, right? And again, what I need to do is P count tar is being renamed into enrollment. And again, we want to use the same notation. R is the rename operation. Now this is going to work on projecting out of this group by. That's the operand. This whatever returned by group by is the operand. And that guy is it's going to group by the mnemonic of this table, which is I want to type that long table name. So let me copy this. If you do a simple search, you will find all kinds of page full of Greek letters to do this. I got tired of it when I started teaching this course because we would spend the entire class translating between select, sigma, project pi, and capital sigma, low sigma, and so forth. But enough of this. Let's just use the first letter, and it should be okay. So here, this is good. So what we are saying is create subset by the mnemonic, right? That's all it does. That operation takes a stream of tuples or stream of records and converts them into subsets and sends you those subsets. Now, you get your select on that. Therefore, everything comes out. Guy says, you know what? I want to project the C mnemonic, and I want to do the count star. How many are there in each of those subsets? Now, then comes that rename operator. Say, I want to rename the count star as enrollment. I think don't need this now. Let's see if it reads properly. Are its options and its operand, which is P, its options, and its operands or whatever is returned by group by, and I need one more to close out this parenthesis. This parenthesis is closed out here. This is closing, the second one is closing this, and this T is closing. So this is the, I mean, it will get, it can get very gnarly because you have to write this and then say whether it makes sense. It is uniform like the statements we have made before. And like I did, you have to write something out and then see what makes sense, take out the parts that don't make sense. So it still retains that structure where you have an operator, options, operand. The options are going to go in square brackets. The operand is going to go in a parenthesis. So in a smaller, when I used to write page queries, this form will reduce it to half a page. It won't be 6 pages. And if you get into the mindset of it, it's easy to process it. And also because it is parsable now, this form is easily understood by deterministic algorithms rather than this. If you say this could have enormous number of other grammatical structure which will yield the same result. Whereas in the relational algebra format, it's just one sentence. This sentence is equal to all the other sentences that will generate the same set. They will all boil down to this one sentence. So you can say, what is the benefit of this? Remember, when you give this query to the database, you're not telling how to do it. You're not telling how to optimize. What it does is it has done all these operations in the past, and it knows what is the performance, what is the cost of doing a certain operation. And it will compute the best, the fastest route sequence of operations to get a task completed and then actually execute. It will cost compare different sentence structures and then use that sentence which yields the result in the lowest amount of. That's what you're getting out of relational algebra. You're getting out of relational algebra the first order predicate calculus language whose meaning will not change and will have isomorphic language sentences. That is, all these technical gibberish means a single sentence is equivalent to many different human formulated sentences. They combine all of them, reduce it to this one sentence, and it'll process this one sentence and determine whether this is the fastest or something else should be used. This is key. And it's an interesting exercise to take even more complicated. You can see how this small query became this, right? All of a sudden, this one is not all that simple anymore. But compared to this, and this guy, a computer will parse this This one is much harder. Because it can be stated in a number of different ways. And you should not get fixated on the simple example I have shown. There could be a join statement which could be written as a subquery, and therefore there are multiple ways of specifying the same result set, extracting the same result set, and so a computer will get lost in all of those equivalent forms. Once it gets to this, there is no confusion here because it's a recursive algebra. It just says bring up the operator, bring out its operands, bring out its options, which is easy, right? So it will just keep giving that until the whole thing is processed, right? So you can see G is the operator, the mnemonic is the option, T is the operand here. That whole thing becomes the operand to this project operator, which takes the C mnemonic, count star, and once that count star comes out, the rename operator says, okay, whatever comes out, if there is a column, count star, make it input. Very easy to process. That is, you can go when we start using not exist and all, we could existence operations and membership tests. This relational algebra becomes inadequate. We'll have to use relational calculus, which introduces those two operations. But generally, I've skipped relational calculus. I've never seen it. This I've used in my experience. The relational calculus I've never used ever. So I don't waste time on that. I've got plenty of time, plenty of material to cover without relational calculus. Are there any questions on the relational algebra part? And just to give you an idea, we're not going to talk in finals, we're not going to have such questions. If you ever encounter relational algebra, I would say just do a search and integrate material from the internet to be conversant in relational algebra. We are just covering it just to say whatever is mentioned in the syllabus, we have dealt with it. Any questions? Okay, so while those aspects of relational databases are very critical, effective, and useful, there is one capability that a relational database offers which is not offered by anything else, and therefore relational databases have come to rule information processing world. It doesn't matter what business you're doing, what domain you're doing, there will always be a relational database running. And the reason that companies use relational databases is even without knowing what a transaction, what concurrency is, enormous corporations can deal with simultaneous operations without being concerned about parallel processing. You probably have heard of issues with parallel processing or concurrent processing. To give you an idea of the difference between this, right? So if it is parallel processing, T1, some process T1 starts, and it is T2, and it ends, let's say, time 2. In parallel processing, another process, T2, will also be running during this interval T1, T2. Alongside T1, right? And there is the other relaxed form is concurrent. This one is slightly different. T1 starts T1, right? And let's say there's time 3. Let's say this is some kind of interval time 3. Here, T2 is stopped. Right? And T1 is started. So what has happened now in the concurrent scenario, we have multiple processes being interleaved, but never simultaneously doing something. It appears like I am working, you are working, everybody is working simultaneously, but it's only concurrent. That is, some of the processes will start before earlier processes have stopped, right? So this one, some processes will start before earlier processes have ended. Right. This is different from sequential processing, where no process can start while another process is running. These are the models, right? Three models: parallel, concurrent, and sequential. The minute you go to concurrent, what will happen is if you have a critical section, that is some area where some people are reading from it and some processes are writing to it, as soon as you have that RW section, we can overwrite each other. So if all of us start sharing a Blackboard, assuming we can virtually overwrite whatever is on the Blackboard, it's not going to be an orderly increment of one. Some of the increments will be lost. So we will never, if I give you the instruction, look at the Blackboard, take the number, and add one, write it back to the board. Because there are so many students, and they're all going to see starting number one. So everybody's going to come up with two, put that two back, and therefore right off the bat, I've lost the count. Because there is no way to prevent multiple processes from viewing and updating information in the shared read-write segment. And we want to prevent that. And in order to prevent that, the following has to be guaranteed. Who knows what is ACID? Anybody know what ACID is? In this class, we ever discussed what ACID is?
I don't believe so.
I don't think so either, because A stands for atomic, C stands for consistent, I for isolation, D for durability. I'll explain all of it. Suppose, let's perform a simple exercise. We'll take all the students, everybody will do that same task. 10 pieces of this watch, 9 ways of configuring them, 9 steps, and randomly, we will never interrupt 3 of those students. The other students will keep interrupting them. We keep asking, are you done yet? Which step are you at? You have all the parts. So if I did this, who do you think will finish the task sooner? The people that are interrupted or the people that are not? So the people that are not interrupted will finish faster. The other metaphor we can compare is if you go on I-95, which has no interrupt, no signals, you will reach Boston faster than if you drive on some country road, right? If you drive from Newark Airport by Garden State Parkway, which has no interrupt, as opposed to Route 9 to the Tappan Zee Bridge. Person that's taking the Garden State Bridge will reach faster because there are no interrupts. That's kind of obvious, right? So in relational databases, if you support atomic operations, that is operations that cannot be interrupted, such operations will finish fast. Okay, that's the number one thing. And we want to, if you did something with the database, and if you complete the operation, then if you start with a consistent database state, you will end in a completed consistent state. What does this mean? I want to create a new customer. So I have to enter customer's age, customer's address, customer's name, customer's credit score. There are 5 different things I'm adding to my database. It's not worthwhile if I'm able to add 3 of them and unable to add the other 2. You want to be able to update all 5 of them or 10. That's what the consistency is. It says they're all playing together. An atomic operation says an operation can never be interrupted. It'll complete. The consistency says an operation that completes will leave the database in a consistent state. Consistent to what? Consistent to the business, not to that entire world. Saying, there is my business, this is my scope. When I say delete a customer, this is what happens. When I say add a customer, this is what happens. Every time they say add a customer, if all of those things specified happen, it's a consistency. So consistency says partial updates will not occur. If you ask them to update 5 records, those 5 records will be updated. Will not be, if you said update something where age is less than 30, the reaction or the response would be, I did some of them, not all of them. That is not the response. We don't want that response. That's what consistency says. Isolation is saying each operation executes as if it's operating in isolation. Each operation executes as if it is operating in isolation. Doesn't need to worry about other traffic coming in front, causing problems, all of that. Train track, right? So train track combined with signaling, what happens? You can use a single track to allow vehicular traffic in both directions by using that signal, right? So you can control it so no accidents happen. No two trains will find themselves occupying the same location, right? It's the same thing with isolation. It is as though each operation is the only operation running at the time. There are other operations, but it's not going to be observable. It's going to be completely isolated. Then we got the durability, which is a very important feature. All changes committed to a database will remain committed even after server is shut down. Right, so I run this application and I inserted 5,000 records. Whatever reason, the server died. Because of atomic, consistent, and isolation, because my 5,000 insert completed, I know all of them went in. Nothing was partially inserted. Everything is completely and fully inserted. That's it. The database is in a consistent state, and you need ASIC, these properties, to support concurrent processing in a multitasking environment where multiple tasks could be running. And if you want them to run smoothly, not override, create problems, then you need support for ASIC. So if a bank wants to operate over ATM, right? Since an account can have multiple cards, and somebody could be operating on multiple somebody, hello, you guys are there? Hello?
Yes,
We're here.
we're here.
Yeah, yeah, very good, very good. Because somebody called me and it interrupted. I don't know who they are. But anyway, we want to make sure that multiple operations can proceed in our database. Whatever they commit remain, even if the server crashes, even if the power is pulled off and the system just shut down without any warning. So long as you committed your transaction completed, those updates will remain in the database. They will be there. They will not be, and it'll make sure through proper OS file system API protocol that every byte is flushed out to the file before updating the customer, the programmer, that this transaction has been committed. And therefore now this is the transaction semantic. Therefore now we can say, what's the life cycle of transaction? Because anything, whether it's a database table or database object, everything has a life cycle. Somewhere they created, somewhere they are manipulated, somewhere they are deleted. For us, we start a transaction, and within that transaction, we're going to do a number of updates. Those updates are not visible outside that transaction. That's what that isolation guarantees. I start a transaction and I start updating. Anything I am updating within that transaction is generally not seen by others. What do we mean by this? Let's take an example. Let's say Anderson, one of our classmates, has written a program to say who is taking 435. Which student is taking 435? Is constantly polling them, right? And then in the interim, the bursar's office is registering new students. So the bursar's office is going to start a transaction, add, let's say, Angus as a student. They haven't committed yet. So Angus will not be visible to Anderson, even though he's looking for new students. There are options to set the isolation level so it will allow reads to continue. That is, reading applications can see it, but let's not get muddied up with all those options. There are so many of them, and they are not standard. If you use J2EE, they will standardize it to some extent, but still it doesn't, it's imposed by J2EE. Databases do not provide that, right? So you start a transaction, you start updating them. These updates are not visible to the world. Now you have an option. You've done all the changes you wanted. Only two options. You can say, roll me back to where I started the transaction, so as if you didn't do anything. Or you can say, commit all the updates I have done, changes I have done, and make it available to everybody. So you can either commit or roll back. Start a transaction to all your operations, and then you commit or you roll back. If you commit, the changes you made will become permanent, and that's what is meant by durability. And if you roll back, it'll be like you never did anything. It'll go back to the old one, right? And so that is the extent of transaction. So let me just do a few things here. In order to do this, we need to log in into multiple sessions.
So
I'm
quick
gonna log
question.
in. Yes, sir.
So if I do a transaction but choose to roll back and don't actually commit to any changes, then it's consistent. Is that what it is?
Yeah, because yes, no, it's okay. So it's a steady state, right? Things are moving along. It's a system that's operating continuously. So go back to that instant. You said you started a transaction. When you started the transaction, was that database consistent? There's the reason I'm asking you this question. Answer the question. When you start the transaction, is the database consistent or not? The answer is the database is consistent. Why? Because it always is consistent due to that C. Every time an operation is completed, it has done what the business wanted the operating database to do, either in full or not at all. So it's not like I'll update the age and not write the address or write 8 bytes out of my cell phone and leave out 2 bytes. That won't happen. It'll either write the entire data or none at all at a micro level, right? So the database is always consistent. When you start the transaction, your database is consistent. You did a few things and you don't like it. So you say rollback. It'll go back to where that transaction started. That means go back to that state where the database was consistent. Do you understand?
Yes, sir.
Yeah. So it's like this. Say you are traveling. You made a reservation to San Francisco. Return ticket $400, right? Your friend calls in and says, you know what, I found something on Kayak for $225. What are you going to do at that point? If you're price sensitive like I am, I would say I will cancel my ticket. So you cancel your ticket. Now, don't equate it to real thing. I'm just making up an example, right? Both cancel and reserving are both two different transactions. It'll go to that system and say, hey, this guy is canceling the ticket, release those fees, right? It's the same thing when you say rollback, everything you used, everything you update will all be reversed. You can now ask, how can it do that? I just changed his age from 46 to 32. I'm rolling back. How does it go to 32? There are 1,000 ways to do that. One of them is versioning. You go back to the previous version, right? We all do that sometimes. We create a slide deck and we keep it. We don't like it. We write a new one and we keep moving back and forth. So that's what happens when you roll back. Now, if you commit it, that 42 becomes a state. That is what the business wants. So it's a consistent state that has been committed. And now the durability part of as it kicks in, all committed changes are permanent. Again, you have to ask, what do you mean by permanent? What if I want to delete it tomorrow? Well, until you change, that is, the business wants to change, those values are permanent. It's not like you made a change, and even if you want to change it, the business wants to change it, this cannot be changed. That's not what is being told. What is being told is whatever change you accept and commit will remain consistent, will remain unchanged until you want to change. Until you, meaning the business wants to change. Whenever the business wants to change, they will all change. So this is the start, commit, transaction, rollback semantics. In order for me to highlight this, let me log in one more time so that I have two sessions. I can show you side by side what happened. So here is another session. And I have these tables. I have these two tables. Same number of tables should be available. Now, let's say start transaction. Okay, so I've started transaction. And I'm going to say select count star from roster. 24 records, right? So I'm going to say create table roster 3 as select star from roster. Same 24 rows. I've done it. Should I see roster 3 here? What should happen? Okay, so these are the 2 sessions. It will not, roster 3 is available here. And the reason is this, that describe okay, so roster 3 is available here. Although I did it within a transaction. Why is that? Because I lectured for about half an hour saying, oh, transaction gives you isolation. And then the first thing I do, I create a table, it's there. Table creation is altering the schema. Schema is not being preserved. It's the state of the schema. That means I now have roster 3 here, and I am going to do a select count star from roster 3 or roster 24. I'm going to go in there and say truncate roster. I'm deleting. I deleted it. Now I can take this select and put it up here, the 0. Okay, so that's the same database, same machine, everything's same, but different session. Oh, auto commit is on. It should have been automatically turned off when I did that start transaction. However, it didn't do it. Let's see. So I made auto commit go away, so it's not there. Now I am going to say insert into roster, select star from roster 3. Okay, so there are these 24 rows that I've inserted back. And if I do a select star, count star roster, it is 24, as I should see it. Now, because it is under a transaction, I should not see those 24 here. I added them within this transaction. I can see it in this transaction, and I made this auto commit to be 0, so it won't automatically commit until I commit. And I haven't committed. So this guy is seeing whatever it was seeing absent those 24 inserts. Now, if I say commit, right? I've committed it. If I rerun this again, it'll see the 24. Do you all follow what I did here? This is what we've been talking by transaction. And we could have done the same rollback and it would be the same. So for example, that commit took out the transaction. The transaction is no longer active. Everything I do there will be visible here. So one thing we can do is in this truncate roster 3, I got rid of roster 3. zero records. So I come here, I say start transaction. I started it, and I'm going to say set auto commit equals 0 or off. So whatever I do here will not be visible anywhere. And I am going to repopulate roster 3. Insert into roster 3, select sort from roster. Now it's on this side. Now, if I go back here and say, show me how many records I have in roster 3, it's still 0. Because these 224 changes, inserts, have happened within this transaction. And operations are not being automatically committed. So they are not visible, right? So just pick this and run it this here. Yeah, I see 24 here, see 0 here. And it's the same machine, same database. Two users are viewing this in two different worlds. These two worlds are different. The last time we committed it, this time we are not going to commit, we are going to roll back. Okay, so I'm going to roll back. Now if I'm going to say what's the number of records, it'll be 0. Because this insert we did has been rolled back. Nothing will be there. And no loss here, this guy's view of the world doesn't change because this transaction that happened outside his view rolled back, didn't commit anything. So no change. Is this clear? Okay. Let's take a 15-minute break. So 6:24, we'll reconvene at 6:40 and go through 2 more topics that I think are interesting. We will do indexing and we will do view and talk about their business implications. What do I get by doing indexing? What do I get by doing view? That's what we're going to talk about. If you have any questions about anything we have talked so far, I urge you to bring them up. 6:40 we'll be back. Thank you, guys. Hello? I'll start recording again.
Hello, Professor.
Hey, how's it going?
Hello.
I can hear you. That's good.
Hello.
Hello. So the phone network works. That's awesome. Okay, let's start with indexing. So if you look at the normal process of selecting and projecting, we have to understand how this works internally. Let's say there are 10,000 records and you want to find some record where the first name is Raman, right? Given nothing else, the only thing that can happen is you take the record out, you mark that record as I've seen this record, and see if that record has first name equals Ram, right? And then you go to the next record, and then the next, and then so linearly you're going to be searching that. So if the number of records increase, this average time to retrieve is also going to increase. So it's proportional to n, and it's not a nice situation. We want to turn this around so that no matter how big our collection of records is, we find what we want in constant time. This is a goal. And how can we achieve this? So let me share it. Not much going on, but it's the same thing, but you can see what we have. Right, so. So for this, we do what we call as index. So it's again a real life theme. If you've ever been to a doctor's office or some other library system where they use cataloging and indexing heavily. You say, I want to read about history and Abraham Lincoln. You're not going to search the 14 floors of books in that library. Somebody there is going to say, go to 7th floor and look up OIJ, because that's what they've got, history and Abraham Lincoln books. So you go there and you find it. So they've reduced this effort to retrieve a book in a library of X number of floors to 1 floor. Never more than 1 floor. One oil. If the book is there, you got it. Right? And it's a good metaphor. Keep that example in mind. The same thing happens in a doctor's office. So today I have to call and change my appointment. So I told them my last name is K-N-N-A-N. So they immediately came back and said, what's your birthday? Because my entire family goes to the same doctor, so they have more than one record there under this last name. So the minute I gave my birthday, they could figure out who this is, right? So the indexing scheme, regardless of how it is implemented, the purpose of indexing scheme is to take something that changes rapidly with the number of searchable items to a constant level, whatever that level is. In some cases, it's going to 1 floor, whether that floor is 7th floor, 6th floor, 5th floor, doesn't matter. You just go to that floor, you find what you want. But in the case of doctor's records, you go to a file. In that file folder, there are all these patients with all of them having this particular key that they've given, right? So this is indexing, again, we have to think in terms of its life cycle. So let's see what we can do here. I am going to use something else that I was doing. So let me see whether this record, this table exists. Okay, so I went back to my lab table. Here I think I have a table on start from franchise. So 171, right? So now if I say I want to find all the, I can write some crazy queries. I'm going to put this query up and ask you to explain to me what this query does, right? So 0.05 seconds. While I'm going to let somebody read through this and tell me what this query does, right? And in the meantime, I'm going to add this to our lesson plan today because it should be there. Join franchise B. So A and B are franchises. They are in two different locations. They're not part of the chain. Group by AFR and BFR. Okay. A franchise, B franchise. Okay. Left join. So what is going on here? Who could see what is being attempted here? And I'm going to go to some other tool to make this more understandable query. Format it a little bit. I'm going to go to SQLformatter.org. Like this is an interesting query. We could spend everything remaining on this one thing, but let's not do that. Let me just. Okay, you should still be able to see this. And I'm going to go here, SQL formatter dot. this may be my fundamental problem with my browsers. Recently, Microsoft updated my operating system, and after that, my sound, everything has failed. My browsers don't work. Two of my browsers don't work. Only Firefox works and the audio doesn't work. Okay. So I'm going to put this up here and I'm going to beautify it. Here is what is the query. So if you're able to see it, what is this query doing, you think? You know all the structures. Everything that is there, you already know. It's not something that we have to go over. You already know. Now you need to see how to put this whole logical construct into something that's useful, right? Something that's being attempted. So it might be instructive to see what this table looks like, which is this franchise. And maybe that will then. So the franchise has some location, a revenue figure, and a chain. So let's select star from franchise, limit 10, or limit 20 maybe. So we are seeing under location some townships, and in the chain we are seeing these hotel operators, and in the revenue it's telling us how much they generate as income. We're not given the year or anything like that, so okay, so we have plenty of them. If I want to find the number of franchises, I could say this would tell me, I could only type franchise. Tells me there are 10 franchises. I don't see anything being duplicated. Everything is distinct. The Best Western, Days Inn, Tunnel Arch, Hilton, Holiday Inn, Forward, Marriott, Hotel Radisson, and Redwood. Right? So some of the queries that will be of interest to us to find franchises that operate in different towns. That's what this is doing. This is saying group by franchise chain AFR against itself, as long as the chains are different and operating in different locations. That's what this is doing. So let's see, this is going to be a huge output, so we don't want this. And we're going to say 20. Formatter created this mess. So we made this. Now we see that these franchises, these chains, they're operating in different cities. It would be interesting to put up their location. Let's say we say A dot location, as A loc, and B dot location. Since we are grouping by, we're not going to be able to see that. So I will get rid of that group by because there is something that we can learn from this. So you can see that Hilton and Marriott are operating in Denver. This guy is operating in Wheeling. It didn't really matter whether this guy is operating in Denver or not. Marriott could still be operating in Denver, but the record with Marriott in Wheeling is that Wheeling different from Denver, it qualifies to come up, right? So these are guys that are operating in different towns, even though they could be operating in the same town, right? They could still be, if I ran another query where I said, where I reversed this and I said, I'm going to make it equal. Again, I'm going to do 20. So what happened? I got the Hilton, and these are guys that are operating in the same town, right? So I had previously, I was picking up franchises that do not operate in the same town. So the Hilton, which is operating in Denver, there are so many other towns, the franchises that are operating in other towns. It doesn't mean they are excluded from Denver. This is what I want you to understand. This is the point. That if you look at these two outputs, here this part, we are saying location is same as the location. And this output that's above it is where they're not equal. So somehow you could be thinking when you read this, saying, okay, that means they are not operating in Denver. That's not the case. Against filter Denver, it will never bring red roof in Denver. That's for sure in this output. And in this output, it would only bring if they are in the same town. But since Denver is not Washington, it's also going to find in this not equal to set Red Roof Inn and Washington, which you see, right? So Red Roof Inn, which operates in Denver, also operates in Washington. So when we said, hey, Red Roof Inn not equal to Hilton location, it brings Denver and Washington. It brings Denver and Gatlinburg. Wherever it's not Denver, it shows that there, which we understand. These are other towns that's not Denver where Red Roof Inn is operating. But as in the second query, we are saying, okay, show me only when they are operating in the same town. Now you see this Hilton, which is operating in Denver, and this Red Roof Inn is also operating in Denver. They come out. So this query, right? So this, what is going on here, if you understand this, you'll be very good at people, right? Why we are getting this output like this? Because it's a record by record comparator, only that these records are part of different sets. Saying, at one time it's saying Hilton, Denver, find something not Hilton, and township not equal to Denver. So it finds all these things, even though Red Roof Inn is operating in Denver, right? And it's not able to keep in mind, hey, this guy operates in Denver, therefore I shouldn't be worried about Red Roof Inn operating in Gatlinburg. You should not look at it. It doesn't know to do that. It simply says, I got a record in A, I got a record in B, I'm going to compare that. Yes, this is both Denver, I can't chuck this. So the next record comes in. It says, this is Denver, this is Gatlinburg. Gatlinburg now equals Denver, so I'll output. I'll add it. Even though we have already established that Red Roof Inn is operating in Denver as well as Hilton. All these things are misleading, potentially misleading. As if they are different, and for a good reason. Denver is operating in this Hilton is operating in those other towns that is outputting in the lower bar. Okay, so the comparison of one set with another set as implemented one record at a time without memory creates this confusing output, which doesn't really mean anything, doesn't make any business sense. So this query is saying doing a left join. It finds all those things where the location is not the state. And then it's doing a left join where the location is state. And then it says if that AFR BF is CFR and this BFR equals BFR. Comparing the A and B, first it found all pairs of A and B when their townships did not match. And then it found all those pairs where they did work in one place, one location, any location. And it wants to find what would this say? If CFR and BFR is null, what would that mean? It would mean the left table has records that the right table doesn't have, right? Otherwise, the right table columns won't be null. There is no null in the chain CFR or DFR. Everything is, they're all present. The only reason this would be CFR null is because of this left. It says, even if my join condition, this condition is not satisfied, include the left record, making the right record column null. So, if you translate this into English, it's saying find those franchises that are operating in different cities, never operating in the same city. Right? These are the franchises that will come out of it. Right? And you can see that. We may have to edit that. And yeah. So whenever you want to find something that is not present, here we are saying find those franchise pairs that never operate in the same town, right? So it doesn't exist, but we want to find it. Whenever you want to do that, this is a good technique where you do kind of a cross join and then left join that. The cross product finds every pair possible, every franchise possible, whether they are operating in the same town, not in the same town. It puts them all together. And then here in the cross join, we are saying, hey, I don't want if the locations are the same. So our cross join, the first table, produces those franchise pairs that do not operate in the same town. Because of that SQL problem, it will include even those pairs that are operating in some town together. It doesn't have a way of filtering that out. So it will come there. To filter them out, we say join this, left join this, where I don't find a match. Those pairs will not exist in this. When you do this, you're going to get those franchises that either, in this case, it is going to find everybody who's operating in the same town. They're never operating in, if you find Hilton, you're going to find Marriott in a town. And if you found a Marriott, you're going to find Radisson. That's what this query is doing. Now you may want to think about it and parse it and understand how this thing works. Now, the left join kind of makes it 0.05 seconds, even though we do not have any indexing. Finish this part. So we don't need that. Go to my there is another way to produce the same thing with not using left join, but using not in, right? And this is going to take 4 seconds. We might even have to wait until it finishes because 4 seconds is observable, right? So the same 8 rows, but this is taking 0.28 seconds, 7 times that first query. Is there a way to make it even quicker? No. What we can do, that's it. A little faster. Now we're going to create index them after index, right? So we're going to create PHIDX on franchise. And this is one. We are also, because we are often checking the location, we will also do this. Location IDX franchise. So we're going to create 2 indices. It's not free. This indexing will now cost us space, this space. So let's see what happens to our query when we rerun those queries. We have to, for the create command, we have to specify the type of object we are creating. So just created these indices on all of them. Now let's run those commands which took 38.05, right? This thing without the index took 0.38 seconds. Still taking 0.38 seconds, no change whatsoever. This is interesting. So let's go back to the join and see whether this is still not in, because not in we'll see what this does. It reduced a slight bit, but not a whole lot, because left itself is doing interesting cut of testing and not testing. So it has achieved a lot of things that already has made it very fast. So now why is this not in, not changing a bit? This is the question, right? This we understand. But this not in, it's still, it's like my indexing has no effect on it. Why is that? The in and the not in, they both are membership tasks. And that means they have have to search the entire set for exclusion or inclusion. This in operator and the not in operator result in table scan. So that's why, because it is a table scan and you can't avoid it by indexing, it's running at the same speed. No difference whatsoever. Okay, so this guy is not in. Okay. So, and you can drop this index by just saying drop index IDX, whatever. Drop index. And see what it. I have to look this up. See. Okay. So in order to drop it, you have to say you're dropping index and the name of the index and the table upon which this index is set. Okay, that's index. I have other examples where this exercise adequately reduced. Showed a counterexample where this indexing didn't change. If I think of some useful exercise, I will add them to you. Right now, you can skip that and move on to, all you have to remember is without indexing, any select statement is going to do a linear search. And we don't want linear search. If we know from the user community, hey, we always use the name of the customer, then you can index the name of the customer. So when the name of the customer is given, the select has, well, I got an index. Let me use this index to get at those records back. It's not a linear search. It's a linear search in terms of the indices, but beyond that, it's not searching linearly. The only place where this becomes cumbersome is if a doctor has 100 patients with first name K, like King, Kong, Kang, Cannon, Charles, whatever, right? So then the indexing K will take you to that folder where all these people are kept. Now you got to do a linear search there. So you might encounter that. This also, they call it as hash clash, where you are indexing something. Too many things are indexing to the same value. So it's a very active research topic to find the most efficient hashing mechanism that will not have clashes like that. You might think it's only in information retrieval as what we are studying, but the same problem is being addressed in crypto discipline also, because they are trying to find Bitcoin ID using hashing techniques. So if somebody has mined the Bitcoin and they've got a hash that's unique to them, then they don't want Anderson to mine that and use it and claim that currency. They want to stop that. And so it becomes tricky because this is distributed hashing now, where Anderson is hashing and mining that Bitcoin is not where the other person is mining it. There's no coordination between them. It has to be resolved in a distributed manner. So it becomes very tricky. So if you want to follow this, Ken Berman, Professor Berman, did a lot of research. You might want to look into that. Okay, the other topic that happens, I know some of you have some exposure to financial industry, or we can even take this franchise, right? And let's say I'm a hotel operator, right? I maintain the revenue and the profitability of not one franchise, but every franchise. So I have a database like this. But I don't want people who look at Daisy, who have the privilege, who have access to Daisy, to be looking at the revenue figures of Chronology. So I want to prevent people from accessing certain records based on who they are. And this is not a strange problem or a problem that occurs only in this made-up application domain. I cannot look up Anderson's grade in any course other than the course where I have taught it. I can look up his grade in my course. I cannot look up Nirmala's grade in other courses that Nirmala has taken throughout her study period. So how do we prevent people from accessing grade records where they're not authorized based on who they are? Right? It's an interesting problem to think about it. And it also happens in hospitals. They have something called HIPAA, which really say if you are the patient taking care of a particular individual, then you have access to their medical records. But if you are their spouse or a friend who happens to be in that doctor practicing as a physician, you have no business looking at their medical records. So if you are creating a information architecture to facilitate this kind of access control, what do? So far we have learned so many techniques. I've created databases for you. You have complete access to this database. You create a table, you can branch it to X, and that X will have access to that entire table, all the records. And yet we want in this scenario where one doctor cannot see the medical records of patients that he is not taking care, or like the case where instructor is not supposed to see the previous grades obtained by students in other courses. How do we prevent this? We don't want to go and create 10 different tables for 10 different instructors. That's nonsense. You'll be duplicating data, right? So we don't want that. So we want to create one table data and yet provide access to only those things that they are entitled to. If I give access to that table, game over. They'll see everything. That's where a view comes in. So I could take view, right? And so for example, I'm just making this up, right? So I have this franchise. I have this. I have location, revenue, and change, right? So let's say I have another table. I create a table called create table management person P. And change. Suppose I have right? Now I'm going to insert into manage. Select. Substring LOK 1, O. Right? I'm just making this up. And change from so for each chain, I'm going to get a lot of people who are somehow managing that particular change revenue. Let me also do this. I think there is such a function. Now this is the 2-character person. I'm hoping they're all going to be different. See what happens. So I got 171. So now this management table has these individual who are supposed to be taking care of different chains. Oh. So I have truncated that original junk table and I added everything from the second character of the first character, which happened to be single quotes. Now I should get something reasonable, right? So now I could say, if you're HD, you could only see filters, right? So I already know they are, so I could create a view like this. Create view, management view. What is this view? This is select franchise So we now have a management view. I can describe it as if it is a table, but this is going to show which person P can see which chain. And I'm not created a separate table. It's not a real table. This is only a made up logical view into this without consuming additional disk space than merely doing this. So if I want to create a view for somebody who I know is part of Hilton, right? So I would say if I want to create from management view where P equals, let's say, Rn, it exists there, I'm going to see only those that this Rn is entitled to see. It cannot see the, what should I say, the data for other franchises for which they have no access to. It's going to prevent them from doing that. And this we have created, if we didn't have this, we would have created 1,700 tables, or God knows, I mean, every time somebody new comes in or moves from one franchise to one chain to another chain, we have to readjust it. But this is different. This view will track wherever the data is and allow only those people with access to view it. And in the same way, if you're a doctor, I can find out the patient you are taking care at the moment. So I can bring you their lab test results, not some other patient. So if you try to pull up your friend's lab results, it is not going to work because this view does not give you access to all patients, but only your patients. It's windowing your access according to whom you are caring for. And because this caring for business keeps changing, the doctor will see me tomorrow and day after tomorrow, he's not the specialist, so he's taken off of my doctors. He's put on to other patients who have problems in his area of expertise, and those are the patients that we get. So this view mechanism that we are seeing here will allow you to see whomever you want to see. And another example is in the finance world, if you look at an option table, you'll have 300 attributes. And they will also have this 300 attributes, out of which about 150 of them will be available to a business group. Another 100 will be available to some other business group. So you can easily do this. You can say, I want column 1, column 4, column 8 to be available to group 1, and C1, C2, C3, C9, some other set of columns to group 2. They can never see what the other person is seeing, even though we have not replicated that data. And this is afforded. This facility is made available to us to view functionality. And I have this here. And this view is, you should always think of it as read only, even though databases managed companies are somewhat aggressive. They try to make other kinds of functions available where you can update to and delete to views. I strongly recommend that you don't do that. Anyway, I will not update or delete without running a simple select, making sure those are the operations those are the records that I want to operate on. I will not simply go and try to update it. I will not simply try to go and delete records. I already told you my horror story at City. I had to stay up all night to do something that was crazy, and nobody should go through that. And that was my own fault. I disobeyed, I disregarded my own discipline. I went and updated without making sure those were the records I wanted to update at a period of time. So you don't want to do that. As you start out, make it a habit. You're going to update. You're going to delete. Delete is more insidious than update. Because once you delete it, nothing is there. It's gone. Update, at least you know you change the column. The rest of the fields are there, so you can go back and do something and get it up. Bad. You didn't do that. But at least you have the skeleton. But if you delete the record, that record is gone. Now you have to do a full insert. And that is a problem. So with this, my friends, we have sort of completed the entire gamut. If you have the appetite for, I can review the whole class, walk through everything we did in this class. But if you have listened to the class review once, twice, and you don't really care about that, I understand it. We can call it quits here. It's your call. Does anybody have any doubt? Would anybody like me to cover any topic again? Insert anomaly, delete anomaly, first normal form, second normal form, third normal form.
Hi. Can you just go over normalization one more time?
Yeah, I also would like you to do that. Thank you.
Okay, very good. Let's do that. Right? So what is the situation with probabilities? Why do we do this? Right? We have to start there. And because if you listen to that story and understand that, then we don't need to worry about particular stuff. One concept there is somewhat hard. So let me just get it up and this is bad because it has got so many columns. So bear with me as we go through this. The main objective of this whole discipline is to optimize my database operation, right? And there are two reasons why database is not optimal. One, data is kept in multiple places. And if you keep it in multiple places and you want to update one, it's not sufficient to update one. You got to update in multiple places. So it's like this. Suppose I have a syllabus and I'm going to give it to Anderson, I'm going to give it to Carmela, I'm going to give it to Angus, and I'm not going to give it to anybody else. Let's say. It's not doable, but let's say we do that. So, and everybody agrees on it, and all the 11 students who have beautifully attended everything, they know these are the 3 people that have the copy of this syllabus. Now, in the middle of the semester, I realized, oh my God, we can't really do this, so I cut out something. And I start updating these people. First of all, I may forget who these 3 people are. Knowing me, that's very real possible. So 2 of them will have some stale, updated, unupdated syllabus, and the other person will have the correct. And so that creates a problem in and of itself. Because some users will go to that person, will get the right syllabus. Other people will go to that other person who has an unupdated copy, and they will get a sales slip. So we don't want multiple copies because they may not always be in all the copies. Even if you think that I'm going to put a guard on Raman, so when he needs to update, everything gets updated. Even if you think that, even if Raman is trying to do it, what will happen? I will start calling Anderson. That'll take 2 seconds. And then I will call Angus. That'll take another 2 seconds. So for 2 seconds, Angus will be off. Even if I try to update them off, because of the nature of distributed communication. If you're going to be in London and somebody's going to be in Tokyo, you're trying to keep London and Tokyo in sync. You cannot keep them in sync at the same time all that. This is Heisenberg's principle of uncertainty, not in physics, but distributed computing, because there is travel time and these bytes to travel over, and during that transit time, things are off. Okay, that's number one, right? Where you kept redundant copies and updating them, keeping them in sync is extremely hard. So therefore, business objectives will not be met. The second problem is if you have fields that are single domain fields, right? So you don't have to parse, you just change the value or retrieve the value that was there. Right? These are the only 2 operations. You want to update somebody's last name, go to that last name field, rewrite the new value. Don't worry about what's there. So updating, deleting single domain fields are relatively easier and faster compared to multi-domain. By saying multi-domain, what we mean is age and name are crossed together. And let's take a simple example of it. I have this small firm invoice box that we looked at. And I'm going to show you.
4 entries and like
What's that?
19 domains. Are you talking about the one with 4 entries and 19 columns or something like that?
Yeah, I'm not sure what 19 has to do anything with it. Can you refresh why you're talking about 19?
No, you said small firm and you did do a file. It had 4 entries, but I believe it was 17 or 19 different columns or domains.
That's correct.
Is that the one
That's
you're
correct.
talking about? Okay, yeah. Just
Yes,
wanted to
yes. So I have pulled out the vendor preferred method of payment, right? So if I agreed to pay in Nala, I could pay it by PayPal, I could pay it by Venmo, I could pay it by Apple, whatever, right? Different mechanisms are there. So I could say check, I could say wireless, and after the work is completed, in how many days will I pay that? And that in the business community is known as terms. These are the terms of payment. So here is the multi-domain column that's given to us. I know it is given to us because my table is named underscore raw. This is what the users gave me and I've loaded them as this. Now if I process it like this and I allow this database feed to remain like this, whenever the user says, the vendor says, you know what, we are no longer accepting checks, we would only accept ACH, then it's not a simple story of go and change this field. I have to go parse this, find everything after ACH or check, and replace it with ACH. And that is a big, big problem, right? It's not straightforward operation. And remember, we need to support assets. The longer your updates are, the more difficult it is to support transactions. I want short, quick transactions so I can provide assets with less impact on my system. The more longer I keep my transactions open, the databases will degrade. Performance of a database will degrade if your transactions are long-lived. You want short-lived transactions. So if you have atomic fields, single domain fields, all updates are going to be short-lived. They're not going to add. There may be other things that is making the transaction longer, but not due to single atomic fields. So these are our drivers to make sure that there are no redundancies. Every domain is single domain. And the business can expand our contract without creating random sparse matrices. What do I mean by this? Harvard, when it started, they taught one course. So students were allowed to take one course, not more than that. Now Harvard, you can take 10 courses. Suppose they kept student and course in one record, and over time, this record now has got 10 courses. Now you can imagine all those people who take 3 courses will have 7 columns empty. Only those students who are taking 10 courses are fully utilizing that record. So anytime you're spending for no additional informational value, that's inefficient. We want to eliminate that. These are our objectives. And Todd, who was a database scientist with some mathematical background, he came up with these rules. First, he said all domains have to be single domain. He understood that if you have a VPMPD field like this, that updating that and maintaining that is more expensive, more time consuming than without it. The first rule is that. Second, he said no repeating. So if you keep 3 courses in the same record, that is challenged by that. Why 3? What's magic about 3? Why not 2? Why not 10? If we can ask all those questions, then there is a problem. And pretty much it'll end up in a database that has too many empty cells. Not every cell is used because some are empty. And the third thing is, as a database grows, this linear search is going to be costly. So we need to find a way to access records faster and faster. So based on all of these realizations, he said all fields have to be atomic, no repeat. Every table must have a primary key. With the definition of primary key being, if you give me a primary key, with that key, I should be able to access access that record with a single key. It doesn't matter how many other records are there. I will be able to access that record given its primary key with a single key, a single access. Same utility as indexing, because indexing is for any field. Primary key is for just that primary key. I can make arbitrarily any column as an index anything, but with the primary key, we are designating one column which the user is saying we will always have it. It's like saying, if you want to cancel reservation, they ask for reservation ID because that's their primary key. It makes it faster for them to delete it. It's the same thing here. So that's first normal form. And you should do it in this order. Get rid of all multi-domain fields, so you have all the columns in your preview. Once you have all the columns, see if there are certain columns that mean the same thing in the real world and they are being held in a record. Get rid of them. Make sure they are in different tables. So you go from a wide format to a long format. Instead of student 1, course 1, course 2, course 3, you're going to have student 1, course 1, student 1, course 2, student 1, course 3. So if the student is taking 6, there will be 6 records. This is called long format, not wide format. And when you do this, a student record will happen if that student is taking a course. If that student is not taking a course, there won't be any record. So no way it's complete. The primary key, again, is allowing you to access them, right? So you got all the fields, you put them in the right place, and now you got the primary keys for these tables. You now can access them. But then what happens if you don't pay attention? Your record may be combining unrelated concepts in the real world. You may be combining instructor with course details. So insert anomaly, delete anomaly will occur. What do we mean by it? The instructor says, I'm not taking this course. And when you delete that, you lose both the instructor record and the course record. So unintended concept. This is delete anomaly, create anomaly. I want to teach a course. I want to become an instructor in a department. I can't do that until I teach a course because this table requires course and instructor simultaneously. So I said, this is insert anomaly. In the test, I'm expecting you to explain this. This is the partial dependency. If I keep all of these columns in one table, and when I go to insert, I'll have to provide unrelated, something not related to what I want to do. I want to add a student. There's no reason for me to add what courses there. It is not relevant. And want to offer this course? Yes. Don't worry about the instructor. Offer the course. Some other time you can make that up. So, and you combine them at a later time. The other, when you are doing this, we have this problem of many to many, right? In all of these cases, when students and the courses are kept together, one student can take many courses. Each course can be taken by many students. So you'll have a many to many relationship. And when you break it, instead of having many to many, all of them will become either one to many or many to many. Right? So that's a better situation than many to many. Many to many is like COVID-19. You want to avoid, you don't want that. It will drain your database that you have that. And you'll have to perform additional checks and balances to make sure you get proper results. So this provides us, leads us to partial dependency. You want to cut, if you had course and instructor's cell phone is not going to depend on course title. And a record that has both course title, course, and instructor will have course and instructor as the primary key, so that you have single record against the primary key. And yet, the instructor's cell phone will not depend on the course product, so it's partial dependency. You want to delete it so that you have appropriately two tables, each one holding on to the information that it needs. If you move past this, and especially if you had a primary key with has multiple components and then multiple non-key attributes, you get to the third normal form where some non-key attributes do not depend on the entire primary key. They depend on something else, which then depends on the primary. And the example we saw was zip code, township, and state. You give me township and state, the zip code is known. The zip code doesn't depend on something else. It only depends on the township and the state. So whenever you have a situation like this, you want to break them apart so that things that depend on each other are in their own little table. Even though for your beginning stage, you say, why do I have all these tables? That's the right thing to do. And it'll result in better performance.
Professor,
And
so for this specific thing, right? For the zip code, since it, are you saying that we should have a table for the city and the state in this case?
yes,
Right, because they both depend.
I would
It's
structure
a non-key
I would
attribute, but it
structure-
depends on the zip code. Okay, I think I finally get that.
No, the thing is, Nirmala, this following is like this. The reason I decide the zip code to depend on indelible facts, right? Of the three things, these are the three attributes we have: city, state, and zip code. What is likely to change? Zip code, more faster than the town's name or the state in which a town is located. So I would make that dependency go with town and state and the zip code depending on those two. It is never, you cannot tell me my town is Washington, give me my zip code. I can't. Because Washington is in every state, right? So you got to tell me the state and the city, then I can give you the zip code. So that's how I would structure it, and it is an example that we do. And if you see, and it's not isolated for database alone. If you are filling out a form, a web form, I get really mad when somebody says, enter your town, enter your state, enter your zip code. Are you kidding me? I gave you the zip code, go find it. Don't ask me to do those kinds of silly things. I'm this valuable species, human, you're supposed to save my time. So I get irritated every time so all these ideas are interrelated, applicable to engineering complex software systems. It's not just database. We are being told as if it is database centric, only because this is a very young discipline and these subjects, the human computer, UX, and software engineering, they were not even there 35 years ago. So the database people were reading along and they created rules, not knowing the same rules will also be relevant for UX people and software. It's like saying 5 plus 3 if you're doing this physics, you add it like this, and if you're doing that physics, add it like that. That's nonsense. I at least challenge it. I tell my students, look, these ideas are same. And I also warn them, don't go and challenge a hiring manager who is interviewing about this. That poor guy was never told this. He didn't have Raman as an instructor. So he might be holding on to this view. So when you present something from my course, reason with them. Well, it looks to me that these are related. I might be able to think of them in similar lines rather than saying, oh, cohesion and coupling. So what the hell is this? That manager will start thinking, what is this candidate telling me about coupling and cohesion, which is to do with software engineering? So they're not connected. So be careful when you do that. That's the story of conversation. We go through these steps. I have given a process of saying statement from which entities and attribute catalog, which contains the domain, the type, foreign key or not, primary key or not, tables they are in, and then slowly move to partial dependency and transitive dependency. You will have CNF. I think if you normalize any architecture to 3NF, you got 95% of performance. Beyond that, even for somebody who's doing billions and billions of search like Google, I don't think they need to worry about. Their worries are different somewhere else. They shouldn't spend time on Packasnar, 3.5, 4.5, 5.5, enough like that. They should rather worry about better search algorithms. Anyway, 808. Did I answer your question, Nirmala? And
You did.
is this clear? Is the story
That part
somewhat
is clear. That part was clear. So are you saying that the zip is the transaction foreign key? I'm having that's the last thing I'm having trouble understanding, even since the exam. The foreign transaction key term just trips me up.
foreign? You somehow you are either into a speakerphone or very muffled. I'm having trouble understanding you today. Can you repeat that again?
I'm having trouble understanding what you mean by foreign transaction key. Whenever I hear that term, it just
Foreign transaction key?
yeah.
I have never said that. I've said foreign key. I've said primary key. What's that transaction key? I've never mentioned that. Are you referring to transitive dependency?
That's what I thought you meant, like on the exam. Like when I heard the term for, I believe Anderson. I don't know if you can correct me on this. Am I crazy? I also went over your office hour with him. You talked about it a little bit, but so I understand the transitive part. What you were talking about, even since you went over it a couple weeks ago. So maybe it's the same thing. I was just a little confused, I guess.
Okay, there is no such thing as transaction key, right? First, let's get that out of the way. We have ideas known as transactions, and we talked about to support transactions, you need to support assets. And we understood why that's the case. ACID stands for atomic, consistency, isolation, and durability. And if you have these four things, then you can support transactions, because the aim of transactions is to allow multiple parties to be collaboratively changing things, possibly impacting each other. And this acid property, if you don't have it, they will definitely override each other screw up the whole system. But if you have asset support, then multiple people can do multiple things. I'm concerned about what someone else is doing because these semantics will prevent somebody from unknowingly, unwittingly affecting somebody else. We saw some examples of how you start transactions and you start making changes within that transaction. Those changes are not visible to the outside sector. Vice versa, right? I could have created 2 sessions, opened 2 transactions, make completely opposite changes in the 2 transactions. They're not going to interact with each other. That's the beauty of transactions. They have nothing to do with keys. Keys make, in order to make a transaction atomic, that is indivisible, the longer the transaction is, the more difficult it is to make it atomic. So this is why I was giving you the example of all the students assembling 15 parts, and some of them never interrupted, and some of them interrupted often. The people that are interrupted will not be able to compete with those people who are never interrupted. So there have been famous experiments done to prove this point. And that's why modular systems, component systems are much easier, more economical to build. Because you build 3, 4 things together, and then you have a component, you put the components together, you're now combining 3 or 4 components and eliminating the probability of interruption, right? So the atomic field, the repeating rules, primary keys, all of them, and indexing, all of them help achieve atomic operations. Operations that can complete without being interrupted. That's it. There is no other connection between them, right? Transactions are a complete word unto itself, where in a distributed processing world, the notion of transaction in the computing world allows multiple parties to be creating and updating shared objects without overriding each other, without undoing each other's steps. That's transaction. Keys are different. When you have primary keys and indexing, which is related, you no longer have to search 100 records one at a time. You get the key tells you where your record is. 1 plus 1 seek, 2 seek. Find the key, 1 seek. Find the location where that key is pointing, second seek, you're done. It doesn't matter if you have 1,000 records or 100,000 records. So 2 seek, constant seek, constant time retrieval, independent of the number of records. That's what keys and indices allow. We have primary keys to say this key is about this table. It has no other difference. I can delete that key from that table. It affects that table, and that's it. Whereas when you have a foreign key, that means that foreign key is residing in this table. To go and find that record in that other table, it is from another table. It's like student course. Student has a primary key, course has a primary key. The enrollment table, which is combining student with course, connect the keys from the student table and from the course table. The key from student table and the key from course table within the enrollment table are referred to as foreign keys because they are not part of enrollment table. They are really borrowed from the student and force table, foreign table, from another table, right? And therefore, there are some operational semantics that we should be worried about. What happens if I delete a course and there are students enrolled in that course? What should happen to them? So there are specific ways to set up foreign case to say this is cascading delete. Therefore, if you delete a parent record, all the subordinate foreign key records in enrollment will also get deleted because they're not valid. If a student drops out of the school, that the student was enrolled in 5 different courses, doesn't mean anything. They all have to be deleted. Those 5 enrollment records have to be deleted. That's what you achieve by cascading foreign keys. And these can be specified at the time of specifying constraints like that. All I would say is go to the internet and say how to set up cascading delete with foreign key. You will see it. It'll say references, cascading, whatever. That there should be a specific sentence. They say it, and you basically get the syntax to set up foreign key with cascading delete. Okay, so I hope your confusion or whatever it is about people I mean, you guys have seen it. I don't remember any of this syntax. I just don't look it up. And so that's what I would say. These are concepts. We have covered all the concepts. And you will, I'm hoping you will use your augmented brain, which is this internet, and you will be able to search smartly and get what you need. So references X on delete cascade. That's it. So all this would tell you is this foreign key is a foreign key, and it will, and the parent is deleted, the child will automatically delete. So you can see building have room. But if you delete the building, the room should go away. So how do you say that? You create the building. You're not telling anything about the room. So you can add buildings without room. Now you create rooms and you give this room number a primary key. And then you give it a building number. And you say a room cannot exist without a building. So you say not now there. And then you say, hey, this building number is a foreign key. It references building in this table, this column, and on delete cascade. So it'll just, and I don't know this syntax. And I don't care. I'll never know this. It's a waste of my brain to carry this information when it's there already. Instead of asking my biological code to search this information, I go to Google, I go to whatever com that is, put in all the terms, it'll give me everything. And that's why my exams are open book. I'm not testing for recall of this. I don't want to test that. I want to see whether you can apply ideas, concepts and validate what you have learned. Comprending. I know my Spanish guy left, worked on me, Leonardo, but and you refused to teach me German. That's okay. So that's so make a note of this and see how this is working, so you can see how all these ideas are kind of related or form a useful function. And as I've said, taking a summer course is not taking my course. Even regular students is a bad idea sometimes. So that's crazy. I admit that, and Anderson will tell you that he dropped my course in spring. So did Anders. Taking
Yep, it was
in
kind of
summer,
difficult.
yes, it's even harder because I don't know if it's whatever it is. Students have to think about this and tell me, Raman, shut up and get out. There are other professors who can teach this.
I do agree, though. This is definitely harder.
Right?
Yes, it definitely is.
Yeah, and in summer, it's like eating 1,000 pizzas in one afternoon. It's impossible. Yeah, I mean, it is very hard. Everybody has to be focused and organized and repeat frequently, often to ferment the ideas later foundation. At least in the real course, I introduce the concept. There is a week in between. We cover it again, waste time, repeat it. It appears very slow, but it's flowing. Here, it's like andale. Even before you know it, it's next andale. You know what? It's extremely hard. Anyway, I hope you learned something. One thing I can offer is anytime you have question about databases, actually persistence, that means not only structured data as well as unstructured, dealing with MongoDB, etc. You don't have to pay any tuition fees. Just shoot me an email if you have a question or two. I'm happy to help you. I'm happy to brainstorm with you. If I can help, I'll definitely provide that. Okay, any other question?
How much of the second half after the midterm is going to be on this exam, in addition to the normalization?
Okay, so the final is going to be exactly the same format as the midterm, where I give you a problem statement and I ask you to normalize, explain. This will carry 40 to 50% of the finals weight, and then 5 queries on those normalized schema to generate something. Create the tables, run the queries, put it all in the same format. I'll set up some Blackboard tests where you add all of this up. Last will create an attribute catalog. I'll show you the first normal form tables, second normal form tables, third normal form tables, explain, and then run these reports, generate these reports. So write a query to report to do this, write a query to do this. Good?
Thank you, Professor. Appreciate it.
You're welcome. And like I said, you don't have a class. This is the last class on Monday, is it? If you come to class at 5 o'clock, your finals should be waiting for you. You just take that and move on. If you have a question, email me. Most probably I'm not going to be available on collaborate at that time. So I'm doing my best to make sure it's very simple and straightforward. Actually, the exams you have taken are much simpler compared to the regular semester. I've already done that. But it will be even simpler because I kind of feel it's a very
What time on Monday will it be closed? It's open from
Class
5 to
timing.
what time?
5 to 8:10. The same. I think final exams are usually CUNY offers them over 2 hours. I'm
Okay.
going to relax a little bit and say I'll make it 3 hours. So take it 3 hours. Quickly you should be working alone, but if you feel the need to talk to somebody else, don't copy. Make sure it doesn't look like copied record, because if it appears copied, I become very cranky. I'm usually very friendly guy, very easygoing. One thing that offends me to my core is when I made it open book, open note, some people decide they could just copy. Copying is so different from collaborating. If you and Nirmala sit down and talk and come up with an approach to solve a problem together, I like that. I encourage that. But it should not be Shante did all the work on problem 3 and Nirmala did everything in 4, and you just need to change the answer. So all the errors and everything is coming through in every one. And that pisses me off. And I change the rule. If you change the game, like rules of the games like that, I change the rules. I make it extremely hard. It becomes what I don't want to be. I'm forced to be what I am not. So don't do that. Anything other than that, you can do it. You can pretty much look up the internet, watch the shows. I keep telling students, always when we go through a class like this, video 10 on this day, 40th minute, talks about X. Just keep recording, indexing this. So when you have a trouble, hit that index button, go there, and so what the hell did Ram say about this on this day? Just do it and put it on the reference. Some students did that. You said this in record number, session number 3, 49th minute or whatever. How can I argue with that? That's very easy. Okay, so that's what I would say. I'm also available. If you send me an email saying I don't know how to do this, I will try to help you out.
How about a text message instead of an email?
Text message, no.
No? Okay. Just email. Gotcha.
Only email. You should email me, and I don't want text messages.
Okay. All right.
Multiple formats. What happens, Angus? When you have multiple input, then people keep texting me and I can't answer email. So one communication channel, I just process material so that nobody is stressed.
Yeah, it makes sense.
Okay, so any other questions?
Not for me. I'm trying to eat. So good night,
No.
Yeah,
Professor.
good.
I don't have any questions, but I did send you an email. I don't know if you got it though, because I didn't hear a response.